National Academy of Mobile Electronics is proud to present a series of training videos for the consumer electronics industry. Each video focuses on a specific area of training with information that has been compiled and painstakingly applied over several years. These videos will make a great addition to your video training library, and if you're just getting started, they will save you hundreds of hours of head scratching. So sit back, take notes, and enjoy. Here's Mike Breault.
Hello, my name is Mike Breault, and welcome to the National Academy of Mobile Electronics. NAME has developed a series of highly comprehensive training videos for the mobile electronics industry. Our videos will help the seasoned professional as well as the novice installer to better enhance their installation skills. We hope you enjoy our videos, and if you have any questions regarding any of our other training programs, please feel free to call our toll-free number during business hours. Now, let's get to work. I've been in the mobile electronics industry for over 16 years, serving in several different capacities. One thing I can say about this industry is you can never know too much. A day wouldn't go by when I didn't learn a new trick about installing or a new technique to implement. Our goal here at NAME is to help you reduce the amount of time you spend on an installation by helping you eliminate the time spent on trial and error. This will make you worth more money to both yourself and to your employer. We're confident that the techniques revealed in these videos will prove effective in your quest to build a better career as a mobile electronics specialist.
I think of all the things that car audio installers can do, and of the many skills that they possess, learning robotics and motorization are among their favorite or most in demand to learn. With the insurgence of high-end car audio, stereo theft is at an all-time high. For this reason, we have looked for alternatives and supplements to add to our security systems. Motorization is being used in many applications in the industry today. Let's look at a few that we have found uses for. One very obvious use for motors is to conceal the head unit to deter would-be thieves. Out of sight, out of mind works here on these installations, in which we have used Tambour doors to complete the job. Tambour is our favorite moving panel to use due to its flexibility and limited space requirements. Here are a couple more uses for Tambour. On this Mustang, it conceals the CD changer and the amp. And on this Thunderbird, it conceals a group of amplifiers and electronic crossovers. It also serves as an advertisement for the manufacturer, whose rep owns this particular vehicle. This motorized panel is strictly for show, which the manufacturer simply wanted to show as much product as possible. There are several more uses for motors. We will cover a few during our video. Now, let's take a look at what we have in store for you. In part 1, we will show you how to build the following panels and doors: Tambour, single hinge, and folding doors. In part 2, we will cover the building of a revolving door panel, the use of mag switches, and another use for a cable drive motor. In part 3, we will cover how to design and build a latching relay circuit, and how to apply these circuits to the motorized panels we have built. Let's begin by going over some of the supplies and materials we'll be using during the course of our video. The two types of wood we will utilize will be 1/8" hardboard and 1/2" medium density fiberboard. The hardboard works great for all of our Tambour projects, and the MDF is to house all of our panels. Here's our glue pot. You've also seen several uses for it during our upholstery video. Here is a canvas mat. This is what we will use during our Tambour door section. Here is a backed carpet. This is very close to a trunk liner, which we'll use for one of our projects. This is a brass piano hinge for our folding door panel. Here is a 1/4 inch steel rod. It will also be used for folding doors. Wooden doweling and rubber wheels come in handy during the tambour door section. Now, let's look at a couple of motors that we will be installing to motorize our panels. This is a continuous cable drive motor by Breault. This particular motor serves just about every need I have found for motorization. It has 66 pounds of torque and a thermal shutoff switch built in. Next we have the ever popular linear actuator. This particular motor has been used probably more in car audio motorization applications than all other motors combined. It is extremely easy to use and it has a built-in limit switch. The built-in limit switch shuts off the actuator when it has reached its maximum extension or full retraction. Here are a couple of Potter Brumfield relays, a door lock actuator, and a momentary rocker switch. The switch is also from Breault. We will be designing and building a circuit in part 3 of our video using single pole double throw relays and this rocker switch. This is a simple, normally open cylindrical magnetic switch. You will also see a simple use of this switch in part 2. Now, let's move on to part 1 and talk about a few different types of doors and panels. We will begin with a basic flip-up door or panel which will act as an amp rack. On this particular job, the customer is interested in showing as much product as possible and is willing to sacrifice his back seat for the ability to do so. Here, in the back seat of this Toyota Supra, we will start by pulling the lower seat. Next, pop the carpet up by using this door panel puller. Alright, now unbolt the rest of the rear seat from the hinges. We will use the existing hinges to bolt and mount the amp rack door to, since it is already very solid and an aligned fixture. Here is a close-up of the center hinge, which will also add strength and stability to our amp rack. Fold the carpet down to eliminate having to cut it out. It also covers an area which may otherwise require finishing. Next, all we have to do is build the housing to hold our amplifiers. We will then vinyl wrap that housing, and then we're on our way. This is the panel we will use to mount our amplifiers to. We will mount 2 amps on the top and 2 on the bottom. The bolts in the panel will be permanently affixed and covered with body filler. The bolts fit right through the hinges. Since all we are doing on this rack is opening and closing the door, and the actuator has an automatic shut-off, the only thing you need to do is decide how to activate your door and where to mount your actuator. Due to the extreme weight included in this amp rack, we choose right down the middle of the rack to mount the actuator for weight distribution. To activate this motor, we chose a relay from the remote turn-on from the head unit. Since this is a show car, having all of the equipment revealed during operation was the reason for choosing the head unit to activate the motor. That was a very basic motorized panel. Let's step up to a bit more complex panel. For training's sake, we will be showing you a panel built outside of the vehicle. This particular type of motorized door requires a bit of room, but in past applications we have been able to build them with half the actual depth of our demonstration model. We will be building flip-up door panels which can be housed in the floor of a trunk, hatchback, or van. We have built similar panels in the rear floor of a Ford Probe, which has an extremely deep hatch area. This particular panel, when carpeted, is virtually impossible to detect and gives quite a bit of storage space below for anything you wish to store, including amplifiers, electronic crossovers, etc. We'll begin with MDF panels, which we have built with a recessed lip all the way around the inside edge. It's recessed about a half an inch to account for the thickness of the doors. We're going to use the half-inch MDF for the doors to offer as much strength as we can so that the trunk is still usable. In this particular panel, we will also house a tambour door below the folding doors. That is the reason for the track in our centerpiece. Now, once you have your panels assembled to your centerpiece, take the 4 panels that will be the doors and place them in place into the housing. Here is where the hinges are installed. Let's first install the piano hinges to the center support and inside your panel. Once your inside panels are in place, open them up, and on the inside edge where the other panel comes together, install a pair of 2-inch hinges. This will allow your door to fold and open in halves. Alright, this is where your 1/4-inch steel rod comes in. First, close your doors and drill a 1/4-inch hole into the side of your doors, and then slot out the side in the sideboards like you see here. Now, take your 1/4-inch steel rod and after putting a 90-degree bend in it, press the rod into the door. Here's what we have so far. The rods are out of the way when fully installed, and a beauty board should be installed to conceal the rest of the moving parts. Next, we will be installing a pair of wheels big enough to move your rod far enough to open your doors. We will use MDF circles to make our wheels since it is the most readily available material we have. Mount a dowel to one of your wheels and drill a hole large enough to insert it through the inside of your box. Placement of this wheel is crucial. This is where we will mount our motor. Here is our motor screwed down to the dowel. Before installing your beauty boards, I will usually mount some type of support housing to the outside of my wheels. If spacing is not limiting, MDF will do. Now let's see how the doors open. Here are the doors opening together to reveal storage compartments in your floor. I use magnetic switches to stop the motor. We will cover the circuitry in part 3. Now, let's move on to our tambour door section. Here, we will need 1/8-inch hardboard, which we will cut into 1-inch strips, just long enough to fit between the track that you wish your door to ride in. Start by laying your strips side by side on a flat surface. Now take a straight edge, or in our case a straight piece of wood, and straighten out the strips. Next, I will take my brad nailer and staple the first strip down. Then, pressing all the strips together, staple down on the last board, keeping them all squeezed together as tightly as possible. Now, realign your strips once the brads are in place. Then, take your glue pot and a piece of canvas material large enough to cover your strips. Proceed to apply the glue to your strips and canvas. When your glue is dry, carefully press and stretch your material over your hardboard strips. At this point, we will take a razor blade and cut the excess canvas from your strips. Also, take your knife and cut the canvas on the outside of the strip next to the two outside strips which you have stapled down. And here's what you end up with. A nice bendable tambour door. You may treat this door in any way you wish. You can take a router and you can router off your edges. You may also paint this hardboard. Now let's go on to the use of our tambour door. First we'll go back to our housing which we installed our track in and see if our door fits. It seems to move fairly smoothly. Now we can continue. We'll begin with a couple of small rubber wheels and mount them just inside the track on both sides. You can pick up these wheels at almost any hobby store. Now we will move on to the installation of our motor. In the bottom of our enclosure, we have cut a hole to push our motor gear through. This is the beauty of a cable drive motor. You need limited space for mounting it. You will also need a dowel that goes from one end of your enclosure to the center support housing in which you will attach your motor. On your dowel, you will also install two rubber wheels to roll the tambour door along. Attach the dowel into your gear and then you're in business. Generally, I will put a trim piece up at the door to conceal the dissension into the base for a smoother transition. Now, let's see how it works so far. To control the motor opening and closing, we have placed mag switches in the center housing to close during the end of the door's travel in either direction. We'll cover more on that later. Here are some more examples of Tambour doors in action. This center console houses an AM/FM cassette, a CD player, and a CB radio. It was built from MDF and conformed nicely around the dash of the Chevy Dually and is vinyl wrapped. The dash of this Mustang houses an AM/FM CD controller unit and equalizer. The rear of our Mustang, we have a Tambour door concealing the amplifier and the CD changer. And finally, here's our T-Bird again. We use Tambour to advertise while concealing the amplifiers and crossovers. We will now begin part 2 of our video presentation. We'll start with a rectangular box built out of MDF. This will be a mini version of what you can build to house your amps and other materials. This will be a revolving flip panel and is very easy to build. You will also need 3 pieces of mitered MDF so we can build an isosceles triangular box. In our woodworking video, we talked about how to derive your angles for miter edging. Now assemble your pieces and then put your ends on them. Once we have put our ends on, we need to locate our center of our triangle. To do that, we simply need to find the halfway point on each of the 3 sides and draw a line. From that point, which will be exactly perpendicular to the mark you have made, we will draw a line to the center. Once you have drawn your lines, locating the center is simple. The center is right where the 3 lines cross. These are the swivel mounts we will be using and attaching to the revolving panel. They will be mounted on each end perfectly centered. This procedure is extremely critical in ensuring the proper operation of our motorized panel, so take your time both in finding your center and mounting your swivel mounts. Once your mounts are installed, you can hold your panel and rotate it to ensure even movement. Here is our panel temporarily mounted in our housing. This panel will be mounted with a 1/4 inch protrusion to account for the beauty boards, which we'll be installing later. To give your panel an inconspicuous flat surface, you're going to build a beauty board to mount around the revolving panel. This board may also be the board that you put in your trunk or hatch. Simply cut the outer edge of the panel to shape the area that you will be installing it. Using the contouring technique we showed you in woodworking will make this a snap. For our training, we have built the skirting out of 1/4 inch MDF. We will be attaching the skirting once we have installed our motor and switching circuit. The idea here, as you can see, once your beauty board is installed and carpet laid down, the panel should be well hidden. In the next step, we will be installing our magnetic switch into our panel. But first, let's drill our hole into the housing in an area where it will align with the corner of our box each time the corner aligns with that mark. To do that, drill your hole in your housing. Once we have drilled the hole in your housing large enough to mount your magnetic switch into, be sure your panel is perfectly flush. Then, proceed to drill into your revolving panel in all 3 corners, repeating this step for each corner. Now that you have drilled your holes, the switch side of the mag switch is installed into the housing while the solid cylindrical magnets are pressed into the revolving panel, as you can see here. We will now drill 2 holes, one in each end of our box, centered between your swivel bases. One should be just big enough to mount a wooden dowel into, and the other one you will be running all of your cabling through from your crossovers or amplifiers or any other electronics you may mount in your panel. Next, cut your square holes into your revolving box, big enough to mount your crossovers and amplifiers into. You will also be cutting a large access panel into your enclosure. Here is the access door. Notice the countersunk edge in your wood. We chose an MDF door made out of 1/4 inch MDF to ensure the door will be flush with the front of our piece. We also leave enough clearance around the edge to account for the carpet later. This will allow for a nice press-in fit. This is the hole we have cut to mount an electronic crossover. We have also cut a hole for an amplifier. Our next step will be to mount the front and back of the housing into your enclosure. Notice the area we have left on either side of the enclosure housing. This will be for concealing our motor on one side and our switching circuitry on the other. We will also have our cables for our amps and other electronics out the side. Once we have mounted our revolving box into our housing, we need to mount our dowel to our gear on the cable drive motor. The dowel will then slide through the housing and press into your revolving enclosure. Notice the flexibility of your spall motor cables. It is recommended to give the motor cable a single twist to form a figure 8 with the cables. This works most effectively for our applications. Next, mount your motor on the side of the enclosure. Now we will proceed to part 3 in designing the circuitry for this motorized panel. We begin with our magnetic switch. Press it into the hole which we drilled in the side previously. Be sure the wire side is going to the outside section of your enclosure. Next, mount your cylindrical magnets into the revolving panel. Now take an ohm meter, preferably one that has an audible continuity indicator, and adjust your switches to make when the panel is perfectly flush in all positions. If the switch is opening too soon, then simply push your magnets back into the panel and try again. Once you have adjusted all of your switches, you can mount 3 relays to the side of your enclosure. You will also need a momentary rocker switch that rests open in the center position. I cut the hole for the switch in the top of my enclosure above the area where my relays are mounted. Now, let's proceed to wire our circuit. Here is a list of parts we will need to accomplish this circuit. This includes some things we have already discussed. 3 single-pole double-throw relays, a momentary rocker switch. You may also use a remote alarm output with a 555 time delay circuit, which has a polarity reversing flip-flop circuit built into it instead of a rocker switch. Consult your nearest Radio Shack for this particular circuit and IC. We also have a normally open magnetic switch, your DC motor, and 2 diodes. We will show you a progression of drawings diagramming this circuit for you. This particular circuit we have drawn is a polarity reversing latching circuit. Its purpose for reversing polarity is to run your DC motor in either direction simply by changing polarity. Now start with your 3 relays. We generally use a Bosch or Potter Brumfield single pole double throw relay. They are both good quality relays. Notice the 5 terminal positions on your relay. 85 and 86 represent that of your coil. These are the 2 terminals that we'll apply voltage to in order to energize our relays. Then we have terminal number 30, which is our pole position, number 87A, which is our normally closed terminal when the relay is at rest, and number 87, which is normally open when the relay is at rest. Relay C will control the latching part of the circuit, while relay A and B will give the motor its reversing polarity. To do this, relay A and B will never be energized simultaneously. Relay C will be controlled by the mag switch, while A and B will be controlled by our rocker switch. Begin by hooking the center position of your rocker switch, terminal number 87 from relays A and B, and terminal number 86 on relay C to a positive voltage source. Next, we will hook one side of our rocker switch to number 86 on relay A, and the other side of your rocker switch to number 86 on relay B. As you can see, so far with the initial stages of our diagram, there is no way possible for A and B to be energized at the same time. Next, we'll hook up our grounds. Number 87A on relays A and B will be grounded, and number 87 and number 87A on relay C will go to ground. Also, on relay C, we will hook terminal number 85 to one side of our mag switch while grounding the other side of our switch. The next step is to hook terminal number 85 on relay A and B to terminal number 30 on relay C. From here, we will hook up our motor. Take one side of your motor and hook it to terminal number 30 on relay A. Take the other side of your motor and hook it up to terminal number 30 on relay B. Now, on relay A, hook terminal number 86 to terminal number 30. On relay B, do the same thing. Terminal number 86 goes to terminal number 30. Finally, we will be inserting our diodes. A diode is kind of a one-way check valve. It allows current to pass through in only one direction. It consists of an anode and a cathode. The silver stripe on the end of the diode denotes the cathode side. To be forward biased and allow current to flow, the stripe, or cathode, must be hooked to the negative side of the circuit while the anode goes to the positive side. In our diagram, the schematic symbol for a diode is shown with the line, and it goes to the direction of the 86 on the relays A and B, with the anode going in line towards terminal number 30 on relays A and B. This completes the hookup of our reversing polarity latching circuit. Now, let's apply our circuit to our motorized panel and see how it will work. Before we go any further, let's finish the assembly of our enclosure. Here is our enclosure before we begin the carpeting. We will carpet our enclosure with a trunk liner. This will give our enclosure a very attractive finish. Here is our enclosure finished. This is the access panel that allows you rear access to your electronics and an alternate hidden storage compartment for your valuables. Now, you may build this enclosure into any additional beauty boards to make it appear as though it was flat across the trunk or hatch area. Now, let's ensure our panel flips freely before we affix the dowel inside. Now, let's give our motor a preliminary check. Okay, it flips fine this way. Now back. And now into the other direction. If you would like to slow your motor down, simply add a resistor in line to slow it down a bit. And here you have it, yet another type and use of a motor in an auto installation. Now, let's review. In part 1, we covered a flip-type panel using a linear actuator, how to use the existing parts of an automobile to create a flip-top door, we also covered building a folding door and its operation, and how to build and use a tambour door. In part 2, we taught you how to build a revolving panel, and uses of cable drive motors and mag switches. And finally, in Part 3, we showed you how to design and apply a reversing polarity latching circuit to your revolving door. We have seen literally hundreds of different combinations of motorization used within the industry, and now with the tips and techniques which we have revealed in our video, you may expand on and create some innovative panels and doors of your own. Another training session come and gone. It's a good idea to view all training videos several times for maximum comprehension. Then view them every several months to refresh your skills. Remember, the more you learn, the more you'll earn. On behalf of the staff here at NAME, I would like to thank you again for your support. I'm Mike Breault. Goodbye for now.
This concludes our video presentation. For suggestions for new videos or the release of other training videos, call NAME